So first we have to start off with the substitutions that will need to be made. So first of all, we start with the volumetric charge density of the sphere, which is this symbol, which equals charge over volume, which equals charge over the volume of a sphere, which is 4/3 pi r cubed, which simplified equals 3q over 4 pi r cubed. Then next, we're going to have to plug in the enclosed charge. So using those two, Q equals volumetric charge density times the volume. Next, using Gauss's law, we get that integral of E dA equals charge enclosed over E naught, where E dA just equals E times the surface area, which is E times the surface area of the sphere, which is 4 pi r squared. Sorry, I wrote cubed here, but it is supposed to be squared. I change it in the next part of the video. Next, Q enclosed equals the volumetric charge density times the volume, and then that's still over E naught. So then plugging in what we derived for the volumetric charge density, we get 3Q over 4 pi r cubed times the volume, which is just equal to 4/3 pi r cubed, times 1 over E naught. Then we can cancel out a couple terms to simplify this down, and we're left with Q little r cubed over big R cubed E naught, where little r is the radius to the point P and big R is the radius of the sphere. So next we want to solve for the electric field. So we do E times the surface area, which is 4 pi r squared. Here's where I changed my mistake from earlier. Equals what we just simplified to Q little r cubed over big R cubed times E naught. Solving for E, we get Q little r cubed over big R cubed E naught times 4 pi r squared. Then the r's cancel, and we're left with Q little r over 4 pi r cubed E naught. So now this is where we can start the derivation for the voltage, because we have everything we need that needs to be substituted in. So, making the first simple statement that the voltage equals the negative integral of the electric field times dr. So therefore, it equals the negative electric field from infinity to r, which is outside the sphere, minus the electric field from r, big R to little r, inside the sphere. So then what we just derived is the electric field for the inside the sphere, and outside the sphere we just use the normal equation for the electric field, which is 1 over 4 pi E naught times Q over little r squared dr. And then we subtract the integral from r to little r of what we just derived. So QR over big R cubed E naught 4 pi dr. And then the next step, you take out all of the constants. So for the first one, we're left with Q over 4 pi E naught, and then the integral of 1 over r squared dr, minus taking out the constants from this side. So you would take out Q over 4 pi E naught r big R cubed, and you'd be left with the integral from r to little r of r dr. Next, you would take the integral of each one. So you bring down the constants you took out, and then the integral of 1 over r squared is negative 1 over r, evaluated from infinity to big R, is negative 1 over big R, minus negative 1 over infinity, which is just equal to 0, and then minus the constants we took out, and the integral of r is 1/2 r squared, evaluated from big R to little r, which equals 1/2 r squared minus 1/2 big R squared, which then, multiplying each part, you get negative Q over 4 pi E naught times negative 1 over r, minus q over 4 pi e naught big R cubed times 1/2 little r squared minus 1/2 big R squared. Next you multiply, so q over 4 pi e naught big R minus q r squared, bringing down the 1/2, so 2 times 4 is 8 pi e naught r cubed, plus the same thing over here, q big R squared, 8 pi e naught r cubed. And then the r's cancel, so there's only one big R left on the bottom, and it can now be added with the first term. So you have to use a common denominator and multiply the first term by 2 so that you get 8 pi on the bottom, and then you need to add those two terms together. So by adding them, you would get 3q over 8 pi e naught big R minus the other term, q little r squared over 8 pi e naught r cubed. And then each term has common numbers in it, so if you take out those numbers that I've just circled, which is q over 8 pi e naught big R, you're left with 3 minus little r squared over big R squared. And that is the derivation for the voltage due to a solid sphere.